No matter how quiet or calm it may seem, nothing in the world is ever still. Deep inside every object, even in the air that surrounds us, atoms and molecules are restless moving. All motions, even random dance of atom, is caused by force pushing or pulling. Force act logically so that things in the world move in a way we can understand or predict. The laws of motion were first published in 1987 by English physicist Isaac Newton, who was born in 1642 and died in 1727. Often called Newton's law, they are a part of his book Principia Mathematica, one of the greatest scientific work of all time. Although Newton is known for his various work for like the search of gravity and his main three laws of force or the motion. How these laws were made, how these laws work, let's study, let's learn. So, first we start with his first law of motion. If we talk about the first law of motion, it is called the law of inertia or the first law of motion by Newton. So the first law of motion states that all the things will either stay still or move with a steady speed unless a force acts on them. The idea is called inertia. The more mass something has, the more inertia it has too. So it will more likely to say still or resist change to its motion. Let's study the second law of motion. It states when a force acts on something, it makes it accelerate, go fast, slow, or change direction. The amount of the acceleration depends on the size of the force and the mass of the object. The bigger the force or the lighter the object, the more it accelerates. So it states that force is equals to mass into acceleration, which is F is equals to ma. Take any object's mass is m and the acceleration of this object is a, then the force applied on that object is F. Therefore state F is equals to ma. Now let's talk about the third law of motion, which is very popular and common among every student, and this is the third law of motion. Newton's third law of motion states that when a force acts on something, there is another force that as big as the normal force but in opposite direction. If the original force is called the action, then the opposite force is called the reaction. That's why the third law is often written in the shortened form. Every action has an equal and opposite reaction. So in example, if we take when we hammer a nail, then the nail pushes the hammer back and we feel a force. And many other examples can be seen in our surrounding only, like the boat sailing in the water and pushed by a big huge wooden block. In a summary, we can say all these laws were important for physics and we should be learning these laws. So if you like the video, please press the like button and comment below what video you next and subscribe.